students, today we are going to discuss the equivalent EMF of cells when connected in series, and we are also going to discuss and find the expression for EMF of cells when they are connected in parallel. Apart from these two things, we shall be also discussing the equivalent internal resistances of the combination of cells when they are connected in parallel and when they are connected in series. So let us start, students. Today here is the diagram for series combination of the cells. Means positive terminal of the cell is connected to negative terminal of the another cell, and so on and so forth. So head of one is connected to tail of another, and in this case what you see is the total EMF across the combination will be the summation of all the individual. So we can say that total equivalent series combination equivalent is just the sum of individual EMF of the cells. So we write E series equivalent is equal to E1 plus E2 plus E3, and that written in the summation form we write I is equal to 1 to 3 EI summation. So this is the expression for series equivalent EMF of series combination of three cells. And it is obvious if these cells are having internal resistance R1, internal resistance R2 and internal resistance R3 respectively, then you can see, since they are in series, the equivalent resistances of the equivalent resistance of this combination of series cells will be nothing but the sum of individual internal resistances, that is R series equivalent is equal to R1 plus R2 plus R3, where R is the internal resistance of the cells. Now you see all in the parallel combination, what we have done, we are connecting all the positive terminals to one end of every cell and all the negative terminals to the another end of the another terminal. And then if we say we are drawing I current from this combination, then it must be equal to the sum of individual currents drawn from the individual cells. That means, say I1 current is drawn from E1 cell, I2 is drawn from E2 cell, and I3 is drawn from the E3 cell. Then we have total current drawn from this combination, parallel combination, I must be equal to I1 plus I2 plus I3. But now we also know the Ohm's law, that is V is equal to IR, and therefore I is equal to V upon R. So we have equivalent EMF of the parallel combination of cells divided by the equivalent resistance of the cells. What is the equivalent resistance of the cell? You see the resistances are R1, R2 and R3, and they are connected in parallel. So we have R parallel equivalent equal to 1 by R parallel equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3, that is summation N is equal to 1 to 3 1 by Rn. Now that means this is the equivalent resistance. Now reciprocal of the equivalent resistance is this much. So what you are going to do is you have to divide the potential by the resistance. So the reciprocal of the equivalent is this much. So that further reciprocated will give the value, equivalent value of the parallel combination of internal resistance of the parallel equivalent internal resistance of the parallel combination of the cells. So that means we are reciprocating the reciprocal of the equivalent internal resistance. So 1 upon 1 by Rn, that is equivalent to Rn. So therefore we are writing E upon 1 upon summation 1 by Rn and equal to E1 by R1 plus E2 by R2 plus E3 by R3, because you have to use the formula I is equal to V by R. And therefore we are having this expression. Now you leave the E parallel equivalent on left hand side and carry this thing in the denominator on the right hand side. Since it is 1 upon this much, therefore on changing the side, what will happen? This will go in the denominator, this factor within the bracket. This factor within the bracket will go in the denominator on the right hand side. So that means E1 by R1, E2 plus E2 by R2 plus E3 by R3 whole divided by 1 upon Rn summation n is equal to 1 to 3. Because it was in the reciprocal form, so you can think it is going to the numerator, and from numerator when you change the sign it should go to denominator. So that means this is the equivalent internal EMF of the parallel combination of the cells. And had there been only 2 cells instead of n is equal to 1 to 3, if we have n is equal to 1 to 2 only, then on solving this expression and eliminating these R3 factors, you will get this expression finally. E parallel combination for n is equal to 2, you will get this expression. So I believe that you have understood it, and sometimes we need to have cells in series and parallel combination, and therefore we also need to know what should be the equivalent EMF of the cells of that combination, what should be the internal resistance of the cells for that combinations. So that's all for today. Thank you and have a nice day.